have some fun multiplying rational expressions. Really, there's nothing going on here that we haven't seen already when we actually multiply rational numbers. We take a look and see if we can actually simplify a little bit, and we actually combine like terms. We know how to multiply rational expressions. We just multiply numerators, we multiply denominators, see what's going on. Of course, if we can simplify first, it makes our life easier. Let's check out this example. So here I've got this rational expression multiplied by this one. I see that, in fact, we can simplify, because here I've got w cubed in the numerator, w squared in the denominator. That means I've got 3 copies of w, 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 w. Oh, it's like the internet. www. Dot. Stop. All right, and then the denominator, I just have w, w. So that means that 2 of the numerator's w's can actually simplify with the denominator. Or you can think about it as w raised to the 3 minus 2 exponent, or just w to the first. In particular, these 2 w's can be simplified away. With 2 of the w's here, I'm just left with 1 w on top. Okay, and here also, if we take a look at this, I can actually simplify one of the x's here with one of the x's here, and I'm only be left with 5 x's here. So, after that little simplification, we can now actually produce the product of multiplying everything through. So if we multiply everything through, what do we see? Well, I see 3x squared times 20 x to the 5th. That's in the numerator. And in the denominator, I see 4, and that's been already simplified away, times 21 w to the 4th. Oh, and I made a typo here. Did you see the typo? Let's review. I've got 3x squared, but what about that one lone w? See, I forgot to write that in. Where were you? Huh? I didn't hear you. Okay. You claim you yelled out? I'm sorry, I didn't hear you. So I'm going to write that in right now. There it is. So there's the first numerator multiplied by the second numerator. There's the first denominator multiplied by the second denominator. Good. Okay, now I'm happy. Now you might say, hey, why did you actually multiply 3 times 20 and all that stuff? You can. You could say 60 up here, and you could say 84 here. But actually, I'm going to see if I can simplify, and I like the numbers to be small. So actually, I don't multiply until the very end. If you think that's silly, then great, and then don't do it. But here, when I look at this, I see that I can simplify this 3 with this 21, and I just get a 7. This 4 can actually be divided into 20, and I just get a 5. And I see that little w that I forgot to write in there actually can simplify with one of these w's here, and I'm just left with 3 w's downstairs. And so now when all is said and done, here comes the hardest part of the whole deal, is to see what's left over. So let's check it out. The coefficient is a 5, and what's left? I've got x squared times x to the 5th. For multiplying, what do we do with the exponents if they're the same base? We add, and so we see x to the 7, right? Because I've got xx here, and I've got x, 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 so I have 7 x's together. Divided by, what do I have downstairs in the denominator? I've got a 7, and then I've got w to what exponent? The 3rd. So after all is said and done, this product is equal to that. Let's try another one together. I'm showing you lots of detail here. When you do these, on your own, like for homework or in classes, I bet you'll do it a little bit faster maybe, but I just want you to see how I think about it. You know what I mean? This doesn't really, am I being silly? I don't think so. All right, let's take this product right here. First thing I would do, honestly, is I would see if I can simplify these things by factoring. So whenever possible, I love to factor. I love to factor. So in the numerator, I've got not much going on. X plus 3. Now I'm going to write this in parentheses because I'm multiplying, so I've got to multiply all the quantity here. So I multiply that by x plus 6. If you didn't put the parentheses, you might sort of forget that you've got to do all that FOILing. You actually want to do the multiplication out loud. So you always want to group things in parentheses when you're multiplying. In the denominator, I see I can factor out a 5. Let me actually do that right now live. So that's going to be an x plus 6. And let me just tell you, to be honest with you, I'm already feeling a tingly feeling in my stomach because I can see already I'm going to get a cancellation right there. See? So the cancellation gives a tingle if you let it. This is a perfect square, difference of 2 perfect squares. So So it's x plus 3. I'm getting a tingle. And x minus 3. No tingle. Alright, well now armed with that, again I just took the product of the denominators, since I'm taking the product of these two rational expressions, and notice that I put parentheses around everything. Lots of tingles. And when all the tingling is done, I think we're left with, now, what are we left with in the numerator? Some people would say 0, which is a great mistake. What's really there? There's actually an invisible 1. Invisible 1 is a multiple of everything. If you put 0, then the whole thing would be 0 and you lost it all. So it actually is a 1 divided by 5 times x minus 3. This is a mistake on purpose. Can you see what the mistake is? This just says 5x minus 3. But really I want the 5 multiplied by everything. You've got to put parentheses around that. So that's how I write the answer. But if you want to actually expand that, you can distribute and say 5x minus 15. Either one's correct. If you want to know my favorite, I kind of like this factor. Always like it factor. Always like it factor. Dividing rational expressions, just like dividing rational numbers, no problem. We just take a reciprocal and multiply. So let's check it out together. I start off with this quotient. And what do I see? This equals 5 divided by, or 5 over 7x squared y times, and I take the reciprocal, and I see 7x y to the 4th, all divided by 20x cubed. Now, how do we multiply? We just multiply numerators, multiply denominators, and then hope for the best. Now, you could just say, again, you could, if you want to say 35 right here, that's awesome. But you know what? I'm kind of lazy, and I kind of argue that being lazy sometimes is good. So I'm just going to write all the factors there, and then see if maybe I can find good cancellations and simplifications later in life. You could put parentheses around things if you want, but here it's not necessary, since multiplication we can basically do in any order at all. There's no distributing going on. If there were pluses here, then I'd have to put parentheses. It's a little tricky. Let's take a look here and see. I've got a factor, common factor on the numerator and denominator of 7. I can simplify here with a 5 and the 20 and get a 4 here. I've got an x here and I've got x squareds here, so this completely goes away with one of those. So let's left with 1x there. Let's remember that. Maybe you want to circle it to remind yourself that it's there. I've got y, and just one y here, so this can be simplified with one of these, leave me 3. And if we let all the dust settle, what are we left with in the numerator? Just a y cubed. And in the denominator, I've got a 4. I've got that x, don't forget about that x. And then I've also got x cubed, so together I've got x to the 4th power. And so there is a very, very neat way of expressing this quotient. Not a problem. Let's try one more together. This one is going to actually have some subtracting terms in the numerator and denominator, so I will have to actually group things in parentheses. Again, I'm dividing these rational expressions, so I'm going to take a reciprocal and multiply. And actually, I'm going to also factor at the same time. So I'm going to do a lot of steps here at once. But that's okay, we're all adults, aren't we? So, in the first piece here, the first numerator, I see that I can actually factor out an x cubed. So let me actually pull out that x cubed right now. So that means I'm going to have x to the 2nd power, because I need a total of 5 x's. And then I have to subtract off 9. By the way, in my head, just to let you know what I'm thinking, that's the difference of two perfect squares. I can factor that x plus 3, x minus 3. I'm going to do that in the next step. Just letting you know what I'm thinking. Can I factor the denominator? Oh boy, I hope so. X, this sign is negative, which means I'm going to have to change in signs here. And I need a product of 12 and a difference of negative 1. So I think a 4 and a 3 placed this way. Negative 4x, 3x, that gives me a negative x, perfect. And then this gives me a negative 12. I think the product, this looks good. Now I'm going to multiply, see, one fell swoop, by the reciprocal. becomes the numerator, which I immediately see as the difference of two perfect squares, so I'm going to factor immediately as x plus 4, x minus 4. I'm getting a tingle. Do you see why I'm getting a tingle? I see already I have simplification, so I'm happy. The denominator now is the old numerator. What can I do there? Well, actually, I see I can factor out a common factor of x cubed, which gives me a little tingle. Since I see an x cubed on top here, that's going to be able to go away. What am I left with? I'm left with an x squared minus 1x minus 12. And you can always check your answer by distributing everything through this x cubed through everything. And then I see x to the 5th minus x to the 4th minus 12x cubed. Perfect. Okay. Now, it looks like we can sort of start simplifying a little bit. Before I do that, let me just make one extra step, factoring this, and then we'll simplify everything at once, okay? So if I'm going to factor these now, I see x cubed, x plus 3 times x minus 3 times x plus 4 times x minus 4. Boy, it's a big numerator, huh? Divided by x plus 3, x minus 4, x cubed. And now, can that be factored? Let's see. I'm going to put an x here, different signs. Oh, in fact, you know what? We already factored that here. So we know it's going to be plus 3, x minus 4. Yeah. See, look at this. See? You got to look for patterns. You got to look for coincidences. When you see them, it makes our work a lot easier. Now, let me make one comment. If you were doing this like on your own, if you were running really, really small, a small font, or you were running sort of messy, you might actually make lots of mistakes, even though you know what you're doing. You've got to be really neat, you've got to write large, and you've got to be careful, because you can see how complicated and long this is. It's not hard, it's just complicated. Lots of stuff here. So write carefully, write slowly, make sure you're not being careless, make sure you're not being reckless, make sure you're not being messy. All right, now let's go. This factor can be simplified with that factor. This factor can be simplified with this factor. Now, you might be tempted to say these cancel, or these cancel, but they're not quite the same thing. You see, they're different. So again, you can't be sloppy here. But this term right here can be canceled away with this term right here. And so when all is said and done, what you're actually left with is this product divided by that product. So final answer is x minus 3 times x plus 4, all divided by x plus 3 times x minus 4. That's how I like to write the answer. Now, if someone actually forces us to actually FOIL all that out, we can. But if you have a choice, you want to keep the answer like that, always keep things in factored form. It's much better. If you don't like that, we can actually FOIL it all out and get x squared plus x minus 12, and then in the denominator, x squared minus x minus 12. I want to make a couple of little teeny points here before I close this up, okay? The first point is you might say, hey, wait a minute. Maybe if I factor out a negative 1, I could cancel. But you can't. You really can't. Check it out. If you factored out a negative 1 here, you would switch the signs of everything. So not just would the negative 3 become a positive 3, but the x would now become a negative x. So you can't cancel it with this. Similarly here, if you factor out the negative 1 here. You really can't simplify this anymore. The other thing you might come to is look at this and say, hey, we can keep factoring. Because check it out. The negative 12s go away. And the x squareds go away. And maybe the x's go away. You're left with negative 1. That's a great wrong answer. Remember, you can only cancel and simplify factors, not individual terms that are being added or subtracted. So, in fact, 12 here is not a common factor. It's a thing that I'm subtracting from the top and subtracting from the bottom. Can't cancel it away. Lots of opportunities for lots of very, very classical mistakes. Just be careful. Do not be careless. Do not be reckless. And you're on the road.